Section R.5 is factoring, and that's just undoing what we did in R.4. In R.4, we had problems that said multiply. Can you multiply, let's say, x plus 6 times x minus 6 in your head? Yes, somebody can. What is it? X plus 6 times x minus 6. What is it? X squared minus 36, because you know that when you do the outer and the inner terms on that, they're going to give you 0, and you're just going to end up with a binomial. Well, today we're doing that in reverse. We're taking that binomial and we're factoring it back into the two original binomials that we multiplied together to get x squared minus 36. Factoring means the same thing in algebra that it does in basic math and up the 3rd grade or so. Give me one way that you can factor, let's say, the number 24. How can you factor 24? Just talk loud to me. I can't hear because my ears are 51 years old. What's one way to factor 24?
6 times 4.
That's one way. Give me another way.
1 times 24.
1 times 24? 8 times 3. All right. So there are several answers to the question, how can you factor 24? But there's only one answer to the question, what is 24 factored as completely as possible? Can you figure that out? Factor till it can't be factored anymore. And like your first instinct was, a couple people started drawing a factor tree. That absolutely works.
2 times 2 times 2.
Beautiful. Because 2 times 2 times 2 times 3 does multiply together to give you 24, and all 4 of those numbers are prime numbers. That's why it's factored completely. You factored it until it can't be factored anymore. And that's what we want to do in algebra. Any one of these kinds of factoring, if I just gave you 10 problems in a row of the same kind, after about 2 of them, you'd have the hang of it, and you could run through the other 8 just fine. What makes factoring difficult to some people is realizing what kind of factoring to do on each problem. Now, in intermediate algebra or algebra 2, whatever you had in high school, you probably had a whole day just factoring the difference of 2 squares. You had a whole day just factoring out the greatest common factor and a whole day factoring perfect square trinomials. But in college algebra, since you've seen that before, we just get to do a couple problems of each type. And I'm going to show you this outline that I have for the process of going through and identifying. That's the hard part, identifying what kind of factoring you need to do on each problem. The kind of factoring you need to do is based on how many terms that you have. Getting a tiny bit ahead of myself, so let me back up. If the directions say factor, the very first thing you look for is what? The greatest common factor, the biggest thing that'll go into all 3 terms. If there is a greatest common factor, first thing you do is factor it out. Now, again, because we're going more quickly than the first time you ever saw factoring, for each one of these kinds of factoring, I've given you a couple problems that you could refer to in the book, and then we're going to do 1 or 2. So when you leave today, you should have, I'd say, at least 3 problems that you can view for examples for each type of factoring. But before I forget it, let me show you one other thing. In Momentum, there's where you go to print your notes. Under the Test 1 notes, there's a module called Factoring Videos right here. I know that if you have completely forgotten factoring, if it's been years and years since you had algebra 1 or 2, then maybe 1 or 2 examples of each is not going to be all you need. If you need more than the 1 or 2 that we get done in class today, check out these factoring videos. There are links to Khan Academy. Khan Academy, you can basically teach yourself everything you need to get a bachelor's degree in anything you need. Because Mr. Khan is a genius. He can lecture on anything from history to math to art to engineering. I've listened to a lot of his lectures. He's hired other people who do lectures for him now. But These four are specifically lectures on the different types of factoring that you need to know. Factoring by grouping. The second one is what I call the hard kind, and that's the hard kind because the reason I call it the hard kind is most people need the most practice on that kind. And then other factoring videos. So if an hour is enough for you, do the homework. If an hour is not enough for you, watch the con videos. While I'm in momentum, I'm going to show you one other thing. Maybe you printed it, maybe you didn't. But under the R.5 notes, I posted a factoring flowchart, and I had a heck of a lot of fun typing that once upon a time. I forget, I think the website was Lovely Charts. This is a graphic organization of the very same steps that I have on the handout. Compare the two. You have the notes. The first thing in the notes says always look for a GCF. If there is a GCF, go this way to yes and factor it out. If there isn't a GCF, you can skip that step and go to step 2. How many terms are there? Well, the kind of factoring you do depends on how many terms you have. If you have a difference of 2 squares, that's a binomial. I said that sentence backwards. If you have a binomial, the only kind of binomial we're going to learn to factor is the difference of 2 squares, and there's how you factor it. If you have a trinomial, 3 terms, we're going to talk about a perfect square trinomial, and here's how you factor it. We're going to talk about what I call the easy kind and the hard kind. You'll hear me say that all semester, but you won't find that in the math book because I made it up. And then 4 terms we're going to factor by grouping. What does step 3 say in today's notes?
See if any factors will factor further.
And that's exactly what's on the 3rd tier of this flowchart. After you have factored once, you get to the question, can any factor be factored further? If so, then start back up here. How many terms are there? But once you get to the point where nothing will factor further, then that next to last box is check your answer. When I say what's the best thing about a factoring test, you can either say, I don't know, I just love it so much it's hard to choose. Or you can say it's checkable. Whichever one applies to you. But to me, the best thing about a factoring test is it's checkable. You can always multiply your answer together and make sure that it gives you back what you started. If it does, you can turn in your paper and say, hey, I know I got 100 on this, and I'll just write it on the top. If not, you go back and find your mistake. But it's absolutely checkable. And because factoring is just the first step of many other processes, if we're going to factor and then do another half page of work on a problem, I'm going to make sure that my factoring is correct before I go on and do that rest of the half page of work. So always, always, always check your answers. All right, back to the notes. This is just a step-by-step that really says the very same thing as the outline. Some folks like words, some folks like pictures, so I made them both. Check for the GCF. If there is one, take it out. Look at the number of terms. If you have 2 terms, let's figure out how to factor a difference of 2 squares. In last night's homework, I told you that you didn't have to memorize the multiplication formulas that were in the book. For example, x minus 7 times x plus 7. I said, you don't have to memorize a formula to multiply that. You just know that whenever the outer and the inner terms, or when you have 2 binomials that are identical, except for one has a plus and one has a minus, what's going to happen? Every time. Bring my name tags in here so I can call names. Tell me what's going to happen when you multiply 2 binomials that are identical, except for one has a plus, one has a minus. The middle terms are going to give you 0, so that your answer is just going to be a binomial. Your answer is actually for that, it's just going to be x squared minus 49. Well, x squared minus 49 is what we call the difference of two squares. You have two perfect squares. If you have two perfect squares that are subtracted, then it will factor into two identical binomials, except for one has a plus, one has a minus. All right, that's exactly what this is saying. X squared minus y squared is x plus y times x minus y. Now, actually, I forgot to do my example of GCF before I talked about difference of two squares. Let's back up and do number, whatever that is, 18. Can you think of the biggest number that would go into 60, 48, and 72? If you happen to think of that biggest number, yay. What if you don't happen to think of 12 and you just factor out a 4? Well, then you should notice what's left still has a GCF. You can either get it all in one step or you might have to get it in two steps, but you take out the greatest common factor. How do you decide which power of x's you can factor out? You can take, look up just a second. Ah, yes, yes, yes. You can't take an x cubed from a little guy that only has x to the first. So you can only take out the lowest exponent of each variable. So what's the GCF there? 12, and then the lowest power of the x's is x to the first. The lowest power of the y's is y to the first. So 12xy is my GCF. And then in parentheses beside it, I need to put what's left of each term if I factor out that 12xy. Maybe I'm skilled enough that I can just squint and see. What do you multiply times 12xy to get 60x squared y? 5y? Sounds like you, oops, I'm sorry, you said 5x. I said the wrong thing. 5x. Sounds like you are skilled enough just to squint and figure that out. But if anybody's thinking, where the heck did she get 5x? All you have to do is divide each term by the LCD. And I don't mean LCD, I mean GCF, greatest common factor. Divide each term by the GCF. And that will tell you what's left inside parentheses. The first term reduces to 5x. What is the second term reduced to? Negative 4y. And what does the third term reduce to? 6x squared. Very good. So y'all don't have any problem with GCF. You distribute that 12xy and make sure that it gives you back that trinomial you started with. Now, number 26. What's the first thing you ask yourself? Is there a greatest common factor? Now, the first thing I notice about 26 is, hey, that's the difference of two squares. 36x squared is a perfect square, 9 is a perfect square, and they're subtracted. So it is the difference of two squares, but it makes the problem easier if you factor the GCF out first. So don't skip that step, even if you recognize it as something else special. Still, always take out the GCF first. If you factor out a 9, you're left with 4x squared minus 1. And that's still the difference of two squares. Because it's two perfect squares that are subtracted. What does that factor into? 2x plus 1 times 2x minus 1. Two identical binomials, except for one has a plus, one has a minus. And that's why when I check my answer, the outer and the inner terms will give me 0. Bless you. And I'll only end up with a binomial for my answer. Step 3 is see if any factors will factor further. Will any of those factors factor further? Nope. Step 4, check your answer. I would just go back uphill, all those two to make sure it gives me that. and then distribute the 9 to make sure it gives me what I started with. All right, that's the only binomial that we're going to talk about. I do have a caution for you. The sum of 2 squares cannot be factored. Let's figure out why. Here's a sum of 2 squares, x squared plus 4. My gut thinks that I ought to be able to factor that. It just looks like something that I ought to be able to factor. If you were guessing, what would you guess that would factor into? That's looks like it ought to work. Or some folks say x plus 2 squared, which means the same thing as x plus 2 times x plus 2. If you're writing this down, make sure you put a big old not equals. Why is that not just x plus 2 times x plus 2? Oh, you get a middle term if you had x plus 2 times x plus 2. And sometimes somebody says, well, what about x plus 2 times x minus 2? Why is that not right?
It would be a negative.
That would give you a -4 on the end. So we could keep playing with this sum of 2 squares all day, but we wouldn't find any real factors. And I'm saying real factors to be perfectly correct, because later we're going to talk about imaginary numbers, but not today. There are no real factors that would multiply back together to give you x squared plus 4. So what's that word we use in basic math for a word that, for a number that has no factors other than 1 in itself? That's a prime number. And in algebra, we say that something that cannot be factored is prime. Just like 7 can't be factored other than 1 times 7, x squared plus y squared can't be factored. So let's go on to trinomials. There are 3 kinds of trinomials we're going to factor. A perfect square trinomial. This first one, or the middle one, that I call the easy kind. Again, you won't see that in the book, but I call that the easy kind when the leading coefficient is 1. And you'll see why I call it the easy kind in a minute. This last kind, where the leading coefficient's not 1, if I wasn't lazy, I'd call it the little bit harder kind, but that takes too long to write, so I just call it the hard kind. When we get to these, I'm going to say, is this the easy kind or the hard kind? Easy kind has a leading coefficient of 1, hard kind has a leading coefficient not 1. But before we talk about those two, let's think about this perfect square trinomial. Last night, if I had asked you to multiply x plus 2 times, well, no, if I had asked you to multiply x plus 2 squared, that could have been in your homework last night. You would have said, well, squaring something means multiplying it by itself. So I'm not going to memorize any special formulas. I'm just going to write it down twice and FOIL it. And when you do, and you combine like terms, you get x squared plus 4x plus 4. That 4x in the middle comes from combining the outer and the inner terms. Well, I didn't tell you this yesterday, but that is called a perfect square trinomial. And here's how you recognize a perfect square trinomial. The first test is easy. The first and last terms both have to be perfect squares. X squared and 4 are both perfect squares. First and last terms both have to be positive. X squared and 4 are both positive. It's the third test that's a little bit of a kicker, but it's worth learning. Here's the third test. You take the square root of the first term, which is what? X, the square root of the last term, which would be 2, you multiply those and get x times 2 is 2x. If doubling that gives you the middle term, then it's a perfect square trinomial. And that's worth knowing, because if you recognize a perfect square trinomial, I'm about to hypnotize you now. Watch out, you never know what's happening. When your head thinks perfect square trinomial, from now on, you're going to go 1 parenthesis with a square outside. That's what I get when I factor a perfect square trinomial. If I recognize them, they're super easy to factor. Just take the square root of the first term, the square root of the last term, and the sign of the middle term. Now we're going to do some more of those in just a second, but let me ask you one other thing. Help me make up a perfect square trinomial, because I'm trying to learn to recognize them. If the first term had been, let's say, 49x squared, and the last term was 25, I would be thinking, hey, that could be a perfect square trinomial. But let's figure out what the middle term would have to be in order for that to be a perfect square trinomial. What's the square root of the first term? 7x. What's the square root of the last term? 5. If you multiply those, you get 7x times 5. 35x. What does the middle term have to be? 70. Yeah, double the 35. The middle term would have to be 70x. It could be positive or negative, but that's a perfect square trinomial. And that one would be a pain in the patootie. If I didn't know it was a perfect square trinomial, it could take me a long time to find the answer. But if I recognize that it's a perfect square trinomial, what did your hands almost do when I said perfect square trinomial? Timid people. Yes, 2 people. It's stuck. I hypnotized 2 people. 1 parenthesis with a square outside is always what your answer to a perfect square trinomial looks like. And inside that parentheses, the square root of the first term, the square root of the last term, and always the sign of the middle term. To check that, you would write down 6x minus 5, not 6x, 7x minus 5 from 7x minus 5. If you fold that back out, it would give you the exact perfect square trinomial we started with. So back to this side. Number 32. What's the first question I always ask myself? Is there a GCF? Is there a GCF? Nope. Second thing I ask myself is, how many terms are there? As soon as I see it's a trinomial, I think, hey, is it a perfect square trinomial? Because those are easy. Could it be a perfect square trinomial? Quite possibly, because first and last terms are both perfect squares. Let's do that other test. Square root of the first term would be x. Square root of the last term would be 5. If you multiply those, you'd get, well, if you multiply those, you'd get 5x, and then double it, and sure enough, that's the middle term. So what's the answer going to look like?
X minus 5.
Give them braver there, Luke. It's going to be 1 parenthesis with the square outside. And inside that parentheses, what are you going to have? Square root of the first term, square root of the last term, sign of the middle term. Then do you understand where you get the 10x when you check your answer? Because yesterday somebody said, I don't see where the 10x is going to come from. And I wrote it down twice and folded it, and then they went, oh yeah, that's where the 10x comes from. All right. Perfect square trinomials are easy to factor if you recognize them. But actually, that one would have been pretty easy to factor anyway. Because even if I'd never heard of perfect square trinomial, I would have said, hey, that's the easy kind, because the leading coefficient's 1. If the leading coefficient's 1, I can just put down 2 parentheses and play with it until it comes out right. I could have just said, oh, I'm sorry, it was right here. I could have just said, well, that's the easy kind of trinomial. X squared pretty much has to be x times x. And factors of 25 that have a sum of 10 are 5 and 5. And to get a positive 10, both of those 5s would have to be positive. Whether you wrote your answer this way or this way, doesn't matter to me. But again, this problem makes perfect square trinomials worth learning. Because that one could have been really, really bad if I hadn't recognized it was a perfect square trinomial. So let's talk about the easy kinds another minute. I'm going to make up 4 problems, and I'm going to teach you something about the easy kinds. X squared plus 5x plus 6, x squared minus 5x plus 6, x squared plus 5x minus 6, and x squared minus 5x minus 6. Almost identical. The only thing that changes in those 4 examples are the signs. Well, it turns out that's pretty important. A lot of folks, when they're factoring the easy kind of trinomial, they'll say, I need factors of 6 that give me 5. If I say factors of 6 that give me 5, what pair of factors pops in your head?
3 and 2.
3 and 2. I'm OCD and have to write the little number before the big number, or I start twitching. If I say factors of 6 that give me 5, 2 and 3 are probably the first things that pop in your head, but there are others of factors of 6 that give me 5. 1 and 6 give me 5 if I subtract them. 2 and 3 have a sum of 5. 1 and 6 have a difference of 5. Now that I know that there are 2 pairs of factors of 6 that give me 5, how do I know whether to use the 2 and the 3 or the 1 and the 6? Well, it turns out that that all boils down to the last sign. When the last sign's positive, I'm going to use the factors of 6 that have a sum of 5. But when that last sign is negative, I'm going to use the factors of 6 that have a difference of 5. So the point I'm trying to make is it's not sufficient to say I need factors of 6 that give me 5. I have to be more specific and say I need factors of 6 that have a sum of 5, or I need factors of 6 that have a difference of 5. All 4 of those, I know that when I factor them, I'm just going to get a binomial times a binomial. And I know for all 4 of them, the x squared is going to have to be factored x times x. But on number 1, when I say I need factors of 6 that have a sum of 5, what numbers do I put in the parentheses? Factors of 6 that have a sum of 5. I need the 2 and the 3. Sorry, that got a little bit messy. And I know that to get a positive 5, what would the signs of the 2 and the 3 have to be?
Positive.
It's a positive 2 plus 3 that gives me 5. Now, on number 2, I'm saying the same thing to myself. I need factors of 6 that have a sum of 5. And so I'm going to put the 2 and the 3 in parentheses. But then to get a negative 5, what signs would this 2 and 3 have to have?
A negative and a positive and a plus. To get a negative 6.
No, to get a negative 5 in the middle. Would a positive 3 and a negative 2 give you a negative 5? Right. But the fabulous thing about checking it, or about factoring, is you can put down what you think it is and check it, and if it's not right, you erase it. They would both have to be negative in order to combine to give me a negative 5 for the middle term. So it's all about trying something and checking it. On examples 3 and 4, I'm saying something different to myself. I'm not saying I need factors of 6 that say have a sum of 5, because these last 2 signs are negative. I'm saying I need factors of 6 that have a difference of 5. And that's why for both of those, the numbers I put in parentheses are the 1 and the 6. On example 3, what would the signs of the 1 and 6 have to be if they were to combine and give me a positive 5? How can I get a positive 5 out of a 1 and a 6? Negative 1 plus 6 would give me a positive 5. What would the signs of the 1 and 6 have to be in order to combine to give me a negative 5? Negative 6 plus 1. Those 4 examples were to show you that it's important not just to say I need factors of 6 that give me 5, but I need factors of 6 that either have a sum of 5 or a difference of 5, depending on those last 2 signs. Just to make sure you understand that lesson, I'm making up one more. You do this one real quick. X squared, let me think of what I want it to be. I had it and it went away. Minus 10x minus 24. Actually, I'm going to give you 2. Squared minus 10x plus 24. Neither of them have a GCF. In both of them, the x squared has to be factored into x times x. If I say I need factors of 24 that give me 10, what's the first pair of numbers that probably pops in your head? I'm sorry, what? Yes, 4 and 6. If I say I need factors of 24 that give me 10, then 4 and 6 are probably the first two numbers that pop in your head. Is that what I need on number 5? On number 5, I should be saying I need factors of 24 that have a difference of 10. 4 and 6 don't have a difference of 10. 2 and 12 do. These have a sum of 10. This has a difference of 10. You need to be saying the correct thing to yourself to pick the right pair of numbers. And on number 5, since that last term's negative, I need factors of 24 that have a difference of 10. That's the 2 and the 12. And what would the signs of the 2 and the 12 have to be in order to give you a negative 10 in the middle? Positive 2 and a negative 12. On number 6, help me finish the sentence. I need factors of 24 that have a
difference, sum.
Number 6, the last sign's positive. So I'm saying I need factors of 24 that have a sum of 10. Then I pick the 4 and 6 because those have the sum of 10. And what would the signs have to be if they were to give me a negative 10 in the middle? They would both have to be negative. Now, when you're factoring, it's very helpful to be good with sign numbers. I'd like you to know negative 4 plus negative 6 gives you negative 10 without having to pick up a calculator. If you do have to pick up a calculator, you need to be very careful. Everybody needs to check their factoring, but if you're not good at sign numbers, you need to check it on the calculator. Because if you make one sign mistake on one factor in R.7, what we're going to do today, Wednesday, what we're going to do Monday, if you make a mistake on the first line, that's going to totally throw off what happens on the bottom line. Check your factor. Number 50. What's the first thing I think? First thing I always think.
Greatest common factor.
Is there a greatest common factor on number 50? Nope. Second thing I think is, how many terms does it have? It's a trinomial. And when I see a trinomial, the first thing I think is, hey, could it be a perfect square trinomial? Because those are easy. The first term's a perfect square. The last term's a perfect square. But what would the middle term have to be in order for this to be a perfect square trinomial? You'd have to have x times 4 is 4x. You'd have to have 8x in the middle for that to be a perfect square trinomial. Since it's not, I'm identifying it as the easy kind. And since it's the easy kind, I'm just going to put down 2 parentheses and say x squared pretty much has to be x times x. And then help me finish this sentence. I need factors of 16 that have a sum of 17. God whisper those to you? Sometimes it does. Sometimes I have to go out to the side of my paper and figure it out myself. 16 and 1? And what would the signs have to be in order to give me a negative 17 in the middle? It's a negative 1 minus 16 that gives me negative 17. All right? Just to make sure you've nailed it, you try one more. 54. It's no GCF. It's also the easy kind. Go for it. sentence, you should have said to yourself is I need what? Factors of 8 that have a difference of 2. That's 2 and 4. Does it matter where you put the 2 and where you put the 4? It matters where you put the signs. You can go ahead and put down the 2 and the 4, but what do the signs have to be in order for those to add together to give me a negative 2x in the middle? A positive 2 and a negative 4 is what will combine to give me a negative 2. All right. We talked about the difference of 2 squares. We talked about the very special perfect square trinomial. We talked about the easy kinds. We're up to the little bit harder kind, which I abbreviate as the hard kind, but it's not really that hard. The hard kind, you can either use trial and error or you can use grouping. Let me skip number 60 for a second and go to number 62. Is there a GCF? Nope. How many terms does it have?
3.
3. Could it possibly be a perfect square trinomial? First term's not a perfect square. Not the easy kind, so it must be the little bit harder kind. Let me show you why I think this would be easy to do by trial and error. Trial and error is exactly what it sounds like. You put down 2 parentheses and play with it until it works out. If you like trial and error, you should probably work in pencil. But this one is easy to factor by trial and error because 2x squared pretty much has to be factored how? 2x times x. Nothing else it really can be. And that 1 on the end pretty much has to be factored as what? 1 times 1. Nothing else it can be. And what would the signs have to be in order for the outer and the inner to combine to give you positive 3?
Plus.
Both positive. And that checks. Here's my 2x squared. Here's my 2x outer plus 1x inner. That gives me 3x in the middle. And there's my plus 1 at the end. So trial and error is especially easy when there aren't very many ways you can factor the first term and there aren't very many ways you can factor the last term. There's not a lot of things you could have to try before you lucked upon the right answer. But I don't know that I would want to use that method on number 72. The 3x squared would pretty much have to be 3x times x. But the 8 could either go in as 1 times 8, or 8 times 1, or 2 times 4, or 4 times 2. That's 4 different things I could have to try. So I'm going to show you the other method that you can use on the hard kind of trinomial if you don't like the guess and check method. That's what some folks call trial and error, guess and check. I will say this though, if you're going on to pre-calculus and calculus, you need to get good at trial and error because there's so much to do after the factoring. You don't want to take 4 lines just to use this other method I'm about to show you. If you're going on to pre-calculus, factoring is one of the most important skills you could carry with you from this course to that course. And factoring by trial and error would be something you need to practice because you keep getting faster and faster at it. Before we do 72, I need, since we just said we're going to do this hard kind of trinomial by trial and error or grouping, I need to figure out what grouping means. And according to this C part right here, I'm going to use grouping whenever I have 4 terms. And that would be like number 60. Number 60 has 4 terms. Is there a GCF? Nope, nothing going to go into all 4 terms. So it has 4 terms. What's the only way I know how to factor something with 4 terms? At the top of the page. Grouping. In some problems, I might need to group the first 3 terms and leave the 4th out. In some problems, I might need to rearrange the terms to make it work. In this particular book, there are no problems that you can't just group the first 2 and group the last 2. So let's try that and see what happens. Group the first 2, group the last 2, and factor the GCF out of each group. What could I factor out of that first group?
3.
And also an x. I can factor a 3x out of the first group. And if I do, what will be left inside parentheses? Yep, if you factor a 3x out of a 9x squared minus 6x, that'll leave you 3x minus 2. Now, in order for factor by grouping to work, when I factor the GCF out of the second group, I have to have the same thing left inside parentheses here that I have inside here. But that already is a 3x minus 2. What can I factor out of that? It's tempting to say nothing, but when you say nothing to a math teacher, I think you mean 0. So you were right to say 1. You can factor out a 1, and it may be helpful to write that 1 down because of what comes next. This original problem has 4 terms. How many terms does it have on my second line? It doesn't have 4 terms now, it just has 2 terms, because anything multiplied together is all part of the same term. This is the first term, this is the second term, and the 2 terms have something in common. The 2 terms have a GCF. What is the GCF? They both have a 3x minus 2. That's the GCF, because both terms have it. And then I say, if I factor a 3x minus 2 out of the first term, what's left? 3x. And if I factor a 3x minus 2 out of the second term, what's left? Plus 1. Those 11 we call my leftovers. The idea behind grouping is that if I can group the first 2 and group the last 2, and then when I factor the GCF out of each group, there's a common factor. I can factor out that common factor, and then in the other parentheses, just put what's left of each factor. That will fall back together to give me what I started with. Here's the 9x squared. Outer would be the 3x. Does it matter that that's not the order it's written in up here? No, order doesn't matter when you add. For 6,000 bonus points, what property of math says order doesn't matter when you add? What? I can't hear you. I thought you said it. Oh, I know what you're saying. No, that's the order in which you simplify a long, long problem. But there's this one of 3 big properties in math that says order doesn't matter when you add or when you multiply. Starts with a C. C-O. Oh, so close. C-O-M. C-O-M-M. You don't get the next one, I'm leaving. Yes, commutative. That's the commutative property that says 2 plus 3 is the same as 3 plus 2. 2 times 3 is the same as 3 times 2. Order doesn't matter when you add. So the fact that outer gives me positive 3x and inner gives me negative 6x, and that's not the order that it was written in the original problem, the commutative property said that doesn't matter. And then last, there's my negative 2. One other thing you may have thought, I don't know if anybody thought this when you saw the original problem or not, but did anybody think, hey, the first thing I do there is just combine like terms? Got like terms in the middle. If you thought that, then you're just thinking one step ahead, because if I did combine like terms, I'd have 9x squared minus 3x minus 2. If I combine like terms, I'd have the hard kind of trinomial. I wouldn't think I could use grouping on something that only had 3 terms. But if I can think of a way to split that middle term and make it 4 terms, then I can use grouping. And grouping's easy, I like it. So let's talk about how you figure out how to split that middle term so that you can factor by grouping. Actually, let's try it on number 72. Where is it? Not there. I can't find it. Okay, right there. I like you didn't notice how spastic I am. When I decided I wanted to be a 5th grade cheerleader, that only lasted a very, very brief period of my life. I'm so uncoordinated that the sponsor, you know, for everybody else, she could stand in front and say, do this, do this, do this. She would have to come around behind me and move my arms because I can't do mirror image in my head. It's embarrassing. I never tried cheerleading again. I became a math major after that. Number 72. Is there a GCF? No. How many terms does it have? 3. Could it possibly be one of our favorite perfect square trinomials? No, no way. Could it be the easy kind? No, it's the hard kind. Would you like to try it by grouping? If so, then go ahead. I meant, would you like to try it by trial and error? If so, go ahead and pop down 2 parentheses and play with it till it works out. I factor most trinomials by trial and error because I've practiced enough to get fast at it. But if you don't like trial and error, here's how you decide how to split the middle term. You multiply the 3 times the 8 is 24. And you say, I need factors of 24 that have a, guess what?
Difference of 10.
Difference of 10. I need factors of 24 that have a difference of 10. So I'm not going to pick the 4 and the 6. They have a sum of 10. I'm going to pick the 2 and the 12. And what would the signs of the 2 and the 12 have to be if I was going to combine them and get a negative 10? What did you say? That would be a positive 10. I need signs that would be a negative 10. Negative 12 plus 2. If you're going to factor by grouping, you take that positive 2 and the negative 12 and split the middle term. Write that down and then I'll tell you what I mean. I'm just going to bring that 3x squared and that minus 8 down. But I'm going to use that 2 and that negative 12 to split the middle term. There are 2 ways that I could write this. I could either say negative 10x is positive 2x minus 12x, or I could say negative 12x plus 2x. Either way would give me negative 10. Either way I could handle this. But for reasons that you'll see in just a minute, I try to avoid the middle term being negative when possible. So I'm going to choose to write this as negative 12x plus 2x. Even though if you write it the other way, you should come out with the same answer. That's what I mean when I say split the middle term. I've taken a trinomial and made it have 4 terms so that I could factor by what method? Grouping? Go for it. Finish that by grouping. Look how we did number 60 and do 72 the same way. What can you factor out of the first group?
3x.
A 3x, and if you do, what will be left of that group?
X minus 4.
X minus 4. What can you factor out of the second group?
2.
And if you do, what's left of that group?
X minus 4.
It better be an x minus 4 or my grouping just fell apart. In order for grouping to work, I have to have the same factor left of each term so that I can say it's my GCF. And when I take that away from each term, I'm left with the 3x and the plus 2. And then I can check my answer. That will fall back together to give me the trinomial that I started with. So if you're going on to pre-cal, I would advise you to get good at factoring by trial and error. But if you're not going on to pre-cal and you're just trying to survive college algebra and you know you have trouble factoring and you don't like to try and erase and try and erase and try and erase, then grouping will work on all of them. You don't have to try and erase. All right. We have covered all the kinds of factoring that we're going to cover, but like I said, the hard part of factoring is just from scratch knowing what to do on each problem. As long as you're doing 10 in a row of the same kind, a monkey can factor. But you start mixing them all together, and the hard part is sorting out what kind of factoring to do on each problem. That's why I've created this flow chart, or the picture of the flow chart that I showed you a minute ago. I've got that tattooed on the back of my eyelid. You give me a factoring problem and I'm going to go, is there a GCF? If so, how many terms are there? Well, actually, if so, remove it. And then how many terms are there? I know how to factor binomials. I know how to factor trinomials. I know how to factor 4-term polynomials. And then rinse and repeat. See if it'll factor any further and multiply that together. So let's try that. Let's try the hard sorting out each kind of factoring on these remaining problems that we have. Number 78, what's the first thing you think? Is there a GCF? Yes, what is it? 3, and when you factor out a 3, what's left? All right, let me write down the first thing I heard and ask you if that multiplies back together to give you the binomial you started with. No, that would just give you the negative 27x squared. What would I have to put? Oh, I have to have a 1 there. So that when I distribute the 3, that gives me back both terms that I started with. You factored out the GCF. Look at what's left. How many terms does it have? 2 terms? What's the only special kind of binomial we know how to factor? Difference of two squares, is it that? Is 1 a perfect square? 1 times 1. Is 9x squared a perfect square? Yeah. Are they subtracted? Yeah. So it's the difference of two squares. And I know how to factor the difference of two squares. I know I have to get two identical binomials, except for one has to have a plus and one has to have a minus. So the outer and the inner terms cancel. What are the two terms that multiply back to, two factors that multiply back together to give you 1 minus 9x squared? What's the answer is what I'm asking.
1 and 3x.
1 plus 3x, 1 minus 3x. Now, just in terms of what I would count right on the test, I'm going to say, is this the same? Would it be right on the test to put 3 times 1 plus 3x times, I didn't mean that, I meant 3x plus 1. Oh, on it. I hate it when I'm messy. Would it be the same if I wrote 3 times 3x plus 1 times 3x minus 1? Is that an equivalent right answer? Is 1 plus 3x the same thing as 3x plus 1? That would make everybody commit and vote. Yeah, order doesn't matter when you add. 1 plus 3x is the same as 3x plus 1. Is 1 minus 3x the same thing as 3x minus 1? Order does matter when you subtract. The commutative property doesn't apply to subtraction. If you fold this back together, you're going to get a positive 9x squared. And we didn't start with a positive x squared. So the answer to that question I wrote is no, that's not the same thing and wouldn't be right on the test. Number 88. Some folks who are even more OCD than I am can't stand to have their polynomials in ascending order. That means the exponent's going up. Some folks look at 88 and go, that's backwards. I'm trying to convince you it's okay. You turn it around if you wanted to, but if you turned it around, you'd need to factor out a -1, where if I leave that like it is, it's the easy kind of trinomial because it's just a 1x squared or a -1x squared. I'm just going to put the x as the last term in each binomial instead of the first term of each binomial. And then I kind of have to read the thing backwards to say my sentence here. But I need factors of 14 that have a, go by the last sign, factors of 14 that have a difference of 6. So I'd whisper that to you.
7 and 1.
7 and 1 aren't factors of 14. Those are the only factors of 14, and none of them have a difference of 6. What does that tell you? You could absolutely say not factorable if you want to write that many letters. What short word means the same thing as not factorable? Prime. I'm going to mark that out since I can't use it and say that this is prime. If on the test you forget the word prime, you can write cannot be factored. And that means the same thing. That's what prime means. All right, number 98. What's the first thing you ask yourself?
greatest common factor?
Is there a greatest common factor? No. What's the second thing you ask yourself? How many terms are there? How many terms are there? 2. What's the only kind of binomial we know how to factor? Difference of 2 squares. Do you realize that I'm asking you all these questions to get you to talk out loud, because science shows the more senses you can get involved in learning, the better it sticks. When you're in your room alone at night and nobody can think you're crazy, go ahead and talk out loud, because hearing yourself say, is there a GCF? This is the difference of 2 squares. Saying those words to yourself and hearing them will help you be able to do that on the test. Folks who say, I looked at the test and I just went blank, my suspicion is you didn't have the words in your head to begin with. You just look at a problem and try to figure out what to do without using any words. And words are how humans think. I need to look at that and know that's the difference of 2 squares. And I know that when I factor the difference of 2 squares, I get 2 binomials that are identical, except for one has a plus, one has a minus. So how do you factor x to the 4th minus 1? What does it factor into? X squared plus 1 times x squared minus 1. Does it matter which one of those factors you write first? Nope. Put x squared minus 1 times x squared plus 1, same thing. So why, if this was a 5-point problem on a test, why would I minus 3u if you stopped right there? It's not factored completely. You need to go on down the chart, and step 3 says, can any factor be factored further? How about that x squared plus 1? Can it be factored any further?
No.
Right. The x squared plus 1 is the sum of 2 squares, and it can't be factored any further. I do need to keep up with it. It has to be part of my answer, but it's the x squared minus 1 that will factor further into what? Yep, but it doesn't matter which one of those you write first. The only reason I'm not taking time to check is so that we have time to do all the examples. But if this was a test on factoring, I would not go to the next problem until, at least in my head, I had full of these 2 to make sure it gave me that, and then full of those 2 to make sure it gave me the original problem. All right, 104. What's the first thing you ask yourself? Is there a GCF? I thought for a minute there would be, but no, there's no GCF. How many terms does it have? 3. Could it possibly be our special kind of trinomial? Maybe, because 9x squared is a perfect square, and 16 is a perfect square. And what's that third test? Square root of the first term is 3x, square root of the last term is 4. Multiply those and you get 12x doubled. Gives you the middle term. So it is a perfect square trinomial. And what popped in your head when I said perfect square trinomial? Oh, everybody's becoming. Oh, I thought everybody lost it. Oh, my hypnosis had come unglued. When I say perfect square trinomial, I know that's what my answer looks like. And then inside the parentheses, square root of the first term is 3x. Square root of the last term is 4. What should the sign be? The middle sign, so that when I fold that back out, it gives me a negative 24x in the middle. Can it be factored further? Nope. So that's it. Now here's why perfect square trinomial is worth knowing. If I didn't know perfect square trinomial, I could go, well, that's the hard kind. And I could either put down 2 parentheses and start playing with it, or I could factor by grouping grouping, 9 times 16 is 144. Find factors of 144 that have a sum of 24. Only problem is there are a lot of factors of 144. 1 times 144, 2 times 72, 3 times something. All right, I could have to go way down that list before I found the factors that have a sum of 24. That's why recognizing the perfect square trinomial saves me time. I don't have to go through grouping. All right, let's try to get these last two. 106. I'm not going to be phobic and turn that thing around. I'm going to say, is there a GCF? Nope. Tell me if this is right. Should I be saying I need factors of 16 that have a difference of 11? No, on the hard kind, I have to do what?
Factors of 5 that have a bit something on it.
No, not factors of 5. Factors of, no. On the hard kind, number 72, we didn't say factors of 8 that had a difference of 10. We multiplied first times last and looked for factors of 24 that have a difference of 10. That's what we have to do on the hard kind. So 106, I need factors of 80 that have a difference of 11. And if God whispers that to you, write it down, because he's usually right. But if not, you're going to have to go 1 times 80, that has a difference of 79, too big. 2 times 40, that have a difference of 38, still too big. We won't go 4 and 20, that has a difference of 16, still too big, but do you notice these differences getting smaller? Difference of 80, or difference of 79, difference of 38, difference of 16, that means I'm closing in on it. When I get to 5 and 16, that has a difference of 11, that's what I need. Now, if you're doing trial and error, you just put down 2 parentheses and go for it. I'm only talking to the people who like grouping better. What would the signs have to be in order to give me a positive 11 in the middle?
Positive 6.
A positive 11 is a positive 16 minus 5, or a negative 5 plus 16. I could write it either way, but I prefer not to have the negative in the middle. So I'm going to write this as 5 plus, and then I'm going to split that middle term into, actually when I split it, I'm going to say 5 minus 5x plus 16x minus 16x squared. Don't go any further before you stop and say, is that equivalent to the line above it? Does negative 5x plus 16x really give me positive 11x? Yeah. And when you're sure it's equivalent to what's on the line above it, then you can factor by grouping. What can you factor out of the first group? A 5, and when you do, what does that leave you? 1 minus x. What can you factor out of the second group? 16, and when you do, what does that leave you? Better leave you 1 minus x or your grouping is not working. So what's your GCF? 1 minus x. Is that the same thing if I write x minus 1? Nope, order matters when you subtract. It's got to be 1 minus x, and then what are my left? Oh, I see a typo. Where's the typo? I found it.
You didn't put the x after the 16.
I didn't say GCF to 16x. So my leftovers are 5 plus 16x. If I had time to fold that back together, sure enough, it would give me what I started with. The last one, I'm giving you one more caution, one more thing to watch out for, things I've seen go wrong in the past. Here's a mistake I've seen in the past. I'm thinking, there's no GCF. There are 4 terms. I'm going to factor by grouping. Group the first 2, group the last 2. All of that has zoomed through my head real quickly, but I've messed up. Because why is this not equivalent to what's on the line above it? If I distributed that -1, this would be a -3, and it wasn't a -3. Remember when I said if I have a positive and a negative, I prefer to write the negative first because I don't like to deal with the negative in the middle? Sometimes you have to deal with the negative in the middle. And the way you can deal with the negative in the middle is catch it inside parentheses and put you a plus outside. Is that equivalent to what's on the line above it? Yes, but that's what you need to be checking every step of the way. What can you factor out of the first group?
2x.
I think just a x. Out of the first group?
Yeah.
Just an x. And if I factor out an x, what does that leave me? Something's wrong. Doggone it. Yep. Look up. Make sure you copied that down right. I did not. You can factor an x squared out of the first group, and what does that leave you? X minus 3. What would you have to factor out of the second group in order to be left with the same x?
That negative x is excluded.
Crap. I'm screwing up. On film, darn it. This will be for posterity unless I go on in and lop off number 120. I got careless because I was in a hurry. This was -3x squared and just -x. I factored an x squared out of the first group. That left me an x minus 3. What should I factor out of the second group in order to be left with the same x minus 3? -1. Sure enough, that leaves me x minus 3. So my GCF is what? X minus 3, and what are my leftovers? X squared minus 1, and y, if you leave that on the test, is it not completely correct?
Because you have to factor out the x squared minus.
The difference of 2 squares will factor further. All right, sorry I got in a hurry and messed up on that last one. But just every line, look and make sure it's still equivalent to the line above it. Homework is assignment 3 in my math lab. And don't forget, if this has not been enough to bring factoring fully back to you, watch those Khan Academy videos and Google factoring worksheet with answers. If you Google factoring worksheet with answers, you'll have all the factoring you can do the rest of your life. See ya.